This video includes engine, chassis, electrical. From now, we will study about the engine of the new H1. The H1 is equipped with the common rail A 2.5-liter engine, D4BH Kovac F-type 2.5-liter diesel engine, and the Theta 2.4-liter gasoline engine. A engine is applied with the single roller bush-type 3-stage timing chain. The components are the chain B linking the crankshaft to oil pump and the RH balance shaft, the chain A linking the crankshaft to the high-pressure pump and LH balance shaft, and the chain C linking the high-pressure pump to the intake exhaust camshaft. Then, let's study about the timing mark of each chain. First, chain C. Chain C is for aligning the timing marks of the high-pressure pump and the camshaft. Next, chain B. Chain B is for aligning the timing marks of the crankshaft and the RH balance shaft. Finally, chain A. Chain A is for aligning the timing marks of the crankshaft, high-pressure pump, and the balance shaft LH. For the A engine of the new H1, water cooling type EGR cooler is installed for decreasing the temperature of exhausted gas, which will be recirculating. EGR valve is the device for returning some portion of the exhausted gas to the intake air route for reducing NOx. As the engine ECM receives the signals from every sensor, it performs duty control of the EGR solenoid valve to control the amount of air newly inhaled. Further, new H1A engine is equipped with the lean burn sensor unit, all-range oxygen sensor. The LSU installed in the diesel engine detects the amount of oxygen in the exhausted gas to finally control the EGR valve. The output value of air amount inhaling into the MAFS, mass airflow sensor, is acquired by subtracting the recirculated amount of exhausted gas from the total air amount inhaled into the combustion chamber. The ECM estimates the EGR rate using this value. Even though the EGR valve can be controlled with similar to the set value at ECM using the EGR rate calculated above mentioned method, it cannot use feedback concept. Therefore, the new A 2.5 engine has the LSU all-range oxygen sensor for receiving the result of ECM control through the sensor so that the feedback concept can be applied. As a result, precise EGR control and fuel amount control can be ensured. The turbocharger of the new H1A engine is the VGT type, which makes the turbocharging effect at all range of engine. The internal structure of VGT is that the VGT is comprised of turbocharger units including the variable inlet vane. This VGT is assembled at the turbine housing side. The external crank is assembled at the VGT. It is linked to the vane actuator through the link. Turbine shaft having the turbine wheel and compressor wheel is installed here, and then compressor housing is assembled. The ECM performs the precise duty control of VGT in the H1 engine. The ECM receives input signals from the boost pressure sensor and performs duty control of VGT solenoid valve to control the vane angle in VGT. At low speed and low load condition, it opens the angle of VGT vane in small to increase the speed of compressor wheel so that the turbocharging effect is increased. As it is getting to the higher speed and the higher load condition, the VGT vane angle is getting the wider to control turbocharging having not overpressure. The intercooler of A engine is installed at the front side of the vehicle. The capacity is changed. It is the 5.7 liter, which is larger 1.5 liter than the conventional 4.2 liter. Additional intercooler fan is not installed, but the air temperature in the intercooler can be lowered by the wind generated at driving. The A engine of the new H1 may be equipped with WCC according to the kind of transmission. For manual transmission vehicle, as the temperature of exhausted gas is low at initial driving of cool condition, therefore CO, HC are highly generated so that the WCC is added to the conventional UCC. When exchanging the catalyst, please notice that manual transmission UCC and auto transmission UCC has similar shape, but they are different. Use the correct one. The preheating system of the new H1A engine is glow plug type, the same with conventional one. Next, we will see the component of fuel system in A engine. There are fuel tank of 75 liter, fuel sender in the fuel tank, fuel filter for filtering foreign material in the fuel, low pressure pump integrated with the high pressure pump, MP-ROP, which is the valve for controlling the fuel pressure inlet port, PRV controlling the high pressure pump common rail and fuel pressure at outlet port, and injector spraying the high pressed fuel into the combustion chamber. At first, the fuel sender is the device for indicating the fuel amount in the fuel tank to the driver on the dashboard. The fuel filter is the device for getting rid of the foreign materials from the fuel. The fuel filter consists of hand priming pump for supplying fuel in manual, fuel heater for preventing that paraffin included in fuel is solidified at cold, fuel temperature switch detecting fuel temperature and sending signal to operate the fuel heater, fuel filter filtering foreign material, and water sensor for indicating moisture alarm at dashboard when a lot of moisture is mixed into fuel at filter. The heating for fuel filter of new H1A engine is controlled by BCM, unlike conventional case. BCM drives the fuel filter heater relay for 15 seconds when ignition 1 signal is input by driver. The high pressure pump is driven by the timing chain. It plays role of supplying high pressure fuel to common rail. The high pump is CP1H type, of which performance is enhanced than conventional CP 3.2 type. The max fuel supplying amount of CP1H high pressure pump is 843 cubic millimeters per revolution, which is larger than the conventional one, 677 cubic millimeters per revolution. In addition, the high pressure pump is equipped with a mechanical low pressure fuel supplying pump and the MP-ROP controlling fuel pressure at inlet port. The engine ECM performs the duty control of MP-ROP to control the fuel amount supplying to the high pressure pump. When replacing high pressure pump, reassemble it with careful of extrusion amount of sprocket. If it is extruded more or less than regulated amount, it causes the chain noise. In addition, measuring sprocket gaps of old high-pressure pump and new high-pressure pump make the gap be comply with the regulation. If it is not satisfying regulation, exchange with the graded sprocket to comply with the regulation. Please do not forget it. The grade of sprocket distinguishes the protrusion amount to the arrow mark shown in figure. There are A, B, and C types for sprocket grade. The specification of grade is as shown in the following table. The common rail of new H1A engine is equipped with the fuel pressure sensor and the pressure regulator valve controlling the fuel pressure at outlet port. ECM controls the max pressure lower than 1,600 bar using the MP-ROP controlling fuel pressure at inlet port and PRV controlling fuel pressure at outlet port. The injector of new H1A engine is equipped with IQA type injector. At each injector, database code is marked on the upper side. At exchanging injector, the worker should input the alphanumeric code into the scan tool. This screen shows the fuel flowing diagram of A engine. By operation of low pressure pump installed at high pressure pump, the fuel in the tank is inhaled through the sender. The inhaled fuel is filtered by the fuel filter and supplied to the low-pressure pump. Through MP-ROP, the fuel amount is controlled and fuel is sent to high-pressure pump. High-pressure pump compresses the fuel having low pressure and sends it to common rail. The common rail accumulates the high-pressure fuel. By the pressure regulator valve is installed at the end of the common rail, the high-pressure fuel is controlled. The injector is operated by the signal from the engine ECM and performs the fuel injection in multi-steps. The electric control unit input system inputs the signals of the crankshaft position sensor for detecting engine RPM and exact position of the piston. The camshaft position sensor for distinguish the positions of number 1 cylinder and number 2 cylinder exactly. The fuel pressure sensor for detecting pressure of high-pressed fuel to use it as the fuel pressure feedback signal. The engine coolant temperature sensor for detecting coolant temperature. The boost pressure sensor for controlling VGT in precise. The oxygen sensor for controlling air and fuel ratio by detecting the oxygen density in the exhausted gas from the exhaust manifold. The mass airflow sensor and the intake air temperature sensor for detecting the air amount flown into the engine and the temperature of intake air, and the accelerator position 1 and 2 sensors for getting the driver's intention to the engine ECM. The engine ECM, receiving various signals from every sensors, controls the fuel injection timing through the injector and the fuel amount for changing injection amount. It controls the pressure generated by common rail using the dual pressure control valve. It controls the throttle flap for reducing the engine vibration at off the ignition. It performs the EGR control to recirculate the exhausted gas and for reducing the nitrogen oxide material. It performs the heating plug control for enhancing ignition at cold, maintaining the smooth rotation of engine and reducing exhausted gas. With turbocharger using high-pressed exhaust gas, the intake air can be compressed and it is cooled by intercooler. The engine has high output. Applying with the water cooling type EGR cooler, the exhausted gas circulated by EGR valve is cooled down in force. The combustion temperature of chamber can be decreased. Therefore, the nitrogen oxide material can be reduced remarkably. In view of NVH, applying with balanced shaft, the engine has less noise. D4BH engine is applied with the alternator brace adjusting type. It is easy to perform service and maintenance works for belts. D4BH engine has 2 timing belts. For the timing of the balance shaft, there are timing marks at the crankshaft and the 2 balance shaft. For the other timing belt, the timing can be adjusted by using the timing marks at the crankshaft, the injector pump, and camshaft. Shows the input elements of ECM. There are 2 groups. One is the sensors and actuators installed at electric type injection pump, and the other is the sensors installed at engine and vehicle. Using these various signals from various sensors, the ECM calculates and output. By GE actuator, the fuel amount can be controlled exactly. By TCV, timing control valve, the injection timing is controlled precisely. Then, let's study about positions and functions of the input-output elements. CKP is installed at the transmission housing for detecting the engine RPM. Boost pressure sensor and intake air temperature sensor installed at intake manifold are sensors for measuring the pressure of the booster and temperature of intake air. The coolant temperature sensor is the sensor for compensating the fuel amount by detecting the temperature of the coolant. There are many sensors and actuators in the injection pump. NP sensor is for detecting the RPM of injection pump. GE actuator, CSP, control sleeve position sensor, fuel temperature sensor are embedded type as shown on the screen. TCV is the actuator for controlling the injection timing. TPS, timing position sensor, is the timer piston position sensor checking how amount of the timer piston is moving. EGR solenoid valve is for hindering the nitrogen oxide amount. The glow relay are installed in the relay box. Let's study about Theta 2.4-liter engine. Theta engine was already applied to NF Sonata. However, FR-type Theta engine is applied to the H1 for the first time. Therefore, here we will study about FR-type Theta engine. Comparing FF-type and FR-type Theta engines in difference, the intake manifold of the Theta engine applied to the H1 is changed in shape as shown on screen. The material is made of aluminum but plastic. The material of the exhaust manifold is changed to cast iron from stainless steel. In addition, the positions of alternator and steering pump are changed. The oil filter position is changed also. The Theta engine applied to the H1 is not ETC, but the cable-type throttle body. MAP sensor is used instead of MAF sensor.